So this one's an example of doing node voltage analysis where there are current sources present. And in particular, the question asks us to find the unknown voltage V1 and V2 over here. So in order to approach this with node voltage analysis, we first need to choose a node to be the reference. And looking at the bottom node here, that's the one that has the most branches. And also it's the negative sign on the two unknowns that I'm trying to find. So for those reasons, it's definitely the best choice as the reference node. Then I would need to go and assign names for the other nodes. So in particular, I will write a V1 for this node here, and then a V2 on this node on the right. We should recognize that V1, the node that I've labeled V1, extends all the way along here as well. And so it's just important to recognize, even though we've drawn the circuit diagram with this node spread out, it's actually all the same point as far as our circuit analysis goes. And then our node voltage V1 is actually the unknown that we seek, and similarly for V2 over there. So let's go ahead and actually solve this particular question. So the first thing that we will need to do is write KCL at node V1. And if we do that, then we have on the left-hand side, we have a current source with a current that is entering the node. And so we normally write the currents leaving the node. So I'll need a minus sign there. So that's minus 15 amps as the first term of my Kirchhoff's current law. Then I will have V1 divided by 60 ohms plus V1 divided by 15 ohms. So just moving across each of these branches. And then the final branch will be V1 minus V2 divided by 5 ohms, and I have all of that equal to 0. So I should try and simplify and clean up this equation just a little bit before I go any further. So in particular, I'm going to multiply everything by 60, which is the largest denominator that I have over here. So in particular, I will get 60 times V1 divide 60 plus 60 V1 over 15 plus 60 times V1 minus V2 divided by 5 is equal to 15 times 60. So this gives me V1 plus 4 V1 plus 60 over 5 times V1 minus V2. Does 60 divide 5? Yes. So that will give me 12 is equal to 15 times 60. For that, I will use my calculator. 15 times 60 is 900. And so I'm going to call this here now equation number 1 in my system of equations. Next step would be to apply Kirchhoff's current law at node V2. So let's go ahead and do that. So KCL at node V2, and then I will get the following system or following equation. So I will have V2 minus V1 divided by 5, just looking at that first branch. Just looking at this branch over here. Then moving on to the next branch, the one that moves downwards, that will be plus V2 divided by 2 ohms. And I have 5 amps leaving, so just plus 5 is equal to 0 here. Now I'm going to multiply this equation by 10 in order to eliminate these fractions. So I will just write that 10 times V2 minus V1 divided by 5 plus 10 V2 over 2 plus 50 is equal to 0. And then we can simplify a little bit. So 2 times V2 minus V1 plus 5 V2 is equal to minus 50. And I'm going to call this one my equation number 2. So now what I need to do is solve this system of equations. I have 2 equations and 2 unknowns. So this now is a kind of mathematically well-posed problem. So let's just go ahead and do that. The strategy that I'm going to use is to eliminate one of the variables. So in particular, I'll take equation number 2 that I've just written, and I will solve for, let's choose V1. So I will solve equation number 2 for V1 in order to be able to substitute it back into the first equation. So approaching equation number 2, here I just need to get V1 on its own. So I will expand those brackets, minus 2V1, so 2V2 minus 2V1 plus 5V2 is equal to minus 50. The V1 I will bring to the other side. I'll collect like terms, so I will get 7V2 plus 50 is equal to 2V1, which gives me V1 is 7 over 2 V2 plus 25, just dividing through by 2 here. So this gives me an equation that describes V1, and so I'll call this equation 2a because I started from equation 2 and I've just rearranged that one. So this is 2a, so I can substitute that now into equation 1. So substitute from 2a into equation 1, and then I will be able to solve for my voltage V1. So my equation V1, I will just write that one down again just for our reference. So this is V1 plus 4V1. I should have already tidied this up a little bit perhaps. 12 V1 minus V2 is equal to 900. I'll clean that one up right now. So collecting like terms here, this will give me, for the first term will give me 5V1. I'll expand these brackets, so I have 12V1 minus 12V2 is equal to 900. And then 512 gives me 17V1 minus 12V2 is equal to 900. I probably should have done this above, just this little bit of tidying up. So now I'm ready to substitute in what I know about V1, that was equation 2a. So this will give me 17 times 7 over 2 V2 plus 25 minus 12 V2 is equal to 900. And then now I have one equation, one unknown, so it's just a matter of calculating these values. So I'm just going to evaluate, kind of expand the brackets here, just multiply this out. 17 times 7 divided by 2 is 59.5 V2 plus, so 17 times 25 is 425. Minus 12 V2 is equal to 900. Collecting like terms will give me 59.5 minus 12. 59.5 minus 12 is 47.5. V2 is equal to, this will be 900 minus 425 is 475. Which will give me V2 is 475 divided by 47.5. 475 divided 47.5 is just 10. So V2 is 10 volts. Now I can go back and calculate what V1 will be. So I can use equation 2a for this purpose. It will be a convenient one to use. So I should highlight my final answer for V2. So V2 is just 10 volts. Now I can substitute into equation 2a. And so that will give me, 2a was the following. V1 is 7 over 2 V2 plus 25. And I'll just substitute my numbers in, so that's 7 over 2 times 10 plus 25 and I'll just get out my calculator and multiply these out. So that's 70 divided 2 plus 25 is 60. So V1 is now 60 volts, and I'll just highlight that is my final answer for V1. So that's basically the strategy that you would follow. You can use Kirchhoff's current law when you're writing the node voltages, and the main thing to pay attention to is whether you have a positive sign or a negative sign. So looking at the first example, just to remind ourselves, I had 15 amps entering the node, and therefore I wrote a minus 15 when I did KCL. For the other example, I had 5 amps leaving the node, and therefore when I wrote KCL, I did plus 5. So it's the current leaving is the positive term that I use.